All right, let's dive into a design pattern that you almost certainly use every single day, probably without even thinking about it. We're talking about the iterator pattern. So picture this. You're a programmer, right? And you've got data coming at you in all sorts of shapes and sizes. Sometimes it's a nice, simple list. Easy. But other times it's a complex tree structure, or maybe even this big, messy social network graph. So the question is, how on earth do you write one piece of code that can loop through all of them without a major headache? Well, your first instinct might be to just write custom code for every single type. A standard for loop for the list, maybe a recursive function to crawl through the tree, and some specialized API call for the social graph. And look, that works. But you end up writing the same kind of logic over and over, just tweaked a little bit each time. It gets repetitive, it gets messy, and honestly, it's a total nightmare to maintain. And that gets to the absolute heart of the problem, something we call tight coupling. When your code that uses the data is completely dependent on how that data is stored, you're in a fragile spot. Let's say your team decides to swap out a simple list for a super efficient tree structure later on. Guess what happens? All that looping code you wrote, it just breaks. The goal is to build a world where that change doesn't cause a catastrophe. And this is where the iterator pattern comes in to save the day. Here's the classic definition, straight from the legendary Gang of Four book on design patterns. The key phrase, the real magic, is right there, without exposing its underlying representation. This means your code doesn't need to know or care if it's a list, a tree, or some other crazy structure. It just needs a simple, consistent way to ask, okay, what's the next item? The core idea here is so simple, it's brilliant. We're applying a fundamental design principle called separation of concerns. We're basically saying, hey, collection, your job is to store data. That's it. You're good at it. But the job of walking through that data, the traversal, that should belong to someone else. Let's make this crystal clear with an analogy. Imagine your data collection is the sprawling ancient city of Rome. It's massive, it's complex, and it has incredible sites scattered all over the place. You want to see everything, but you have no idea how the city is laid out. Where do you even start? How do you visit everything in some kind of logical order? Simple. You hire a tour guide. In our analogy, the city of Rome, that's your data collection. All the amazing sites, the Colosseum, the Trevi Fountain, those are the individual elements inside your collection. And the tour guide, that's your iterator. The guide knows the city inside and out, so you don't have to. You just follow along and ask, all right, where are we going next? And this is what makes the pattern so flexible and so powerful. You can have different kinds of tour guides for the very same city. One day, you might use a smartphone app for a quick modern tour. The next day, you might hire a history expert for a really deep dive. It's the exact same idea in programming. You could have an iterator for a social network that shows you all your connections, or a completely different one that only shows you profiles of your coworkers. Same data, just different ways of walking through it. Okay, let's get a little more formal for a second and look at the official blueprint. Now, don't let a diagram like this intimidate you. The key thing to see here is the separation. The client, that's your code, doesn't talk directly to the nitty-gritty details of the collection. Nope. It talks through two clean, separate interfaces, one for the collection, often called an aggregate, and one for the iterator. This separation is the entire source of the pattern's power. So let's quickly break down the players here. The client is just your code that needs to do the looping. The aggregate is the collection, and its main promise is that it knows how to create an iterator for itself. The iterator is the interface that defines those super simple commands we all know, like next and hasNext. And finally, the concrete classes are where the real work happens. That's your actual list or tree and the specific iterator that knows exactly how to navigate it. For your code, the actual process is just beautiful. It's a simple three-step dance. First, your code asks the collection, hey, can I get an iterator? Second, the collection creates the perfect tour guide for its own unique structure and hands it back. From that moment on, your code only talks to the iterator, using simple commands like next to get the next item, until hasNext says, nope, we're all done here. So why go through all this trouble? Well, the payoffs are huge. First, you're following the single responsibility principle. Each class has one job and does it well. The collection stores, the iterator traverses. Second, this lines up perfectly with the open-close principle, which is a fancy way of saying you can add new types of collections or new iterators without breaking any of your existing code. And as a really cool bonus, you can have multiple iterators walking through the same collection at the same time, each keeping track of its own spot. This quote just nails it. It perfectly sums up the entire point of the pattern, to decouple algorithms from containers. When your algorithms, the code that does things with your data, are no longer chained to the containers that hold the data, you get an incredible amount of flexibility. It makes your software so much easier to maintain, to test, and to expand. So I'll leave you with this thought to chew on. The iterator pattern isn't really just about looping. It's a fantastic example of a much bigger, more powerful idea, separating the what you want to do from the how it actually gets done. So take a look at your own projects. Where else could you apply that principle to make your code cleaner, more flexible, and way more robust?